So how does the team do now? They're not getting fiddled in the locker rooms.
Oh, okay. So, yeah, I have no fucking clue. It's really kind of funny because apparently we're doing really well, but it doesn't matter because we're out. Like, we can do as well as we want, but we have no ranking and we have no stakes.
You're not.
Oh yeah,
you're not bowl eligible.
Yeah,
Yeah.
you got punished.
Yeah.
Gee, you think?
Good times.
So after this podcast, I'm fired, right?
From what, your job?
Oh, no, like, you know how you have to do the sexual harassment thing?
Oh, I haven't done that yet.
Yeah, well, guess what we have to do?
Children harassment?
Yes.
You're shitting me.
That's going to be really hard for you, isn't it?
Faculty required children abuse.
So it's okay, awareness, gotcha.
Jesus.
Yes, not faculty required abuse. If one person goes down, we're all going down.
10-year requirement.
Jesus.
Bring your son or daughter to work day.
Oh my god.
Welcome to Paleo After Dark.
So what are we talking about today? Other than the horrible topics that we've already covered.
Yeah. We're talking about the Red Queen.
And not the one from Alice in Wonderland.
Well, sort of.
Well, yeah. I guess I should have specified not the one from American McGee's Alice.
Yeah, I guess that would be accurate.
This one only wanted to kill children.
That's actually true.
Wait, yeah, sure.
Yeah.
The Red Queen wanted to kill Alice. Off with her head.
Yeah.
That was the Queen of Hearts.
That's the Queen of
Whatever.
Hearts. The Red Queen and the White Queen are part of Through the Looking Glass.
Yes.
I don't know and I don't care, and that's getting cut from the podcast.
You don't know and you don't care.
I don't read boring American literature.
Pretty sure Lewis Carroll was British and
Yes.
A Nazi sympathizer.
Was he really?
Yeah, sure.
No, he wasn't. He died before World War I.
I was gonna say, wasn't he around in the Victorian era?
So yes, he supported Nazi-like views.
How can you prove him wrong? Can you ask Lewis Carroll? I think not. Point James.
I would also like to thank the Lewis Carroll estate for not suing us.
Oh, Jesus. We're getting it everywhere, aren't we?
It's alright, we already dodged that bullet with Walt Disney, so...
That's true, that's a fair point. Oh, wait, didn't Disney do an Alice in Wonderland movie? Oh, shit! Now we're, like, double screwed.
Layers upon layers. We made Nazi sympathizer jokes and referenced Alice in Wonderland, ergo we can link it to Disney.
Who was a Nazi sympathizer?
That one's actually true.
Yeah, it kind of is, yeah.
Did Mickey Mouse cartoons for the Fuhrer.
The more you know, kids.
Amanda loves Disney show tunes. We had that conversation earlier.
The ones from, like, the 80s and 90s.
Well, it's not Nazism anymore, it's just white supremacy.
Yeah.
Notice Aladdin isn't Arabian.
Yeah.
Well, I hate to make this argument, but technically if he was Persian...
That's true. He should have a lighter skin tone if he's Persian.
But Persia, Sultanate's post-Persia.
Never mind then.
Oh, okay, yeah. Oh, well.
Satrapies were Persian.
Okay. I learned something new today.
Yeah. So anyway. This is just disturbing. All I see is James just cackling, and
I don't even know what he's laughing about.
You've learnt one thing new so far.
that one really got him. But he enjoyed that.
I'm not sure why. I don't want to know. So
It's just that you learned one thing.
So far.
far. Jesus. Anyway.
Jesus can't help you. He's also wooden, holds a grudge, don't you know?
Do I need to call someone? Like, is this going to be okay in the end?
Who are you going to call? Ghostbusters!
I was holding it back. I knew that joke was so bad. I was just holding it back.
Is this genuine restraint from Curtis in terms of bad jokes?
Sounds like it, which is kind of a shock. Maybe we should buy a lotto ticket.
Oh, I have numbers.
Yeah, that's right.
4, 15, 19, 30, 34, and 40.
If you've won on any of these numbers, please send the money to Paleo After Dark for supplying them to you.
Mm-hmm.
I just liked how official James sounded there. He could have been with the BBC.
Oh, yes, of course. No, he's secretly working with one of those numbers channels. You know about those, right? The
Yeah.
radio channels that just give strange cryptic numbers and nobody knows really why because they're probably military.
Yeah, they're super weird.
I have to eat this after I've read it out.
Yes, otherwise it will explode.
How is eating it gonna... No.
Right, so we're talking about the Red Queen hypothesis. Which...
Yes.
Or metaphor, according to some authors.
Or the Red Queen metaphor, or...
Which is kind of actually really harsh.
Yeah.
Well, I mean, the hypothesis is named after a metaphor. So, I mean, I guess backing up, the Red Queen, if we want a little bit of history, the Red Queen was first named by Van Valen in 1973. And Van Valen, who sadly passed away, I think, about 3 years ago, he's sort of one of the more famous evolutionary and paleontological thinkers. You're just... Why are you just... What are you doing, Amanda? You're chopsticking my face. And James just left. Like, I started talking about history, and James just fucking left. And Amanda starts chopsticking my fucking face. So great. Yeah. Yeah, this is...
Sorry, Curtis. It's been a long day.
What did I miss?
So 1973, Van Valen comes up with this hypothesis called the Red Queen. And does anyone... So, how just as a refresher, does anyone here want to talk about how he came up with the hypothesis? Or should I just keep rattling?
I remember he looked at stuff, but I can't remember what he looked at because my brain is just
Typically,
fried.
people do tend to come up with ideas based upon evidence, as surprising as that might be.
I just can't remember what exactly he looked at. It's just gone.
No problem.
Everything. He looked at
Well,
everything.
yeah, he looked at...
Because everything shows the same pattern.
Stop making Van Valen out to be some sort of crazy person.
Okay, no, it's an interesting theory. It's just I love the very extreme way he couched it. Sometimes.
Oh my god, yes. And in as much detail as humanly possible, to the point where he throws out random mathematical models just to...
And invents
I
a
just
unit
remember-
called the MacArthur.
I just remember charts on top of charts on top of charts.
No,
It's charts all the way down. It's like in the inception of charts.
Okay, so a little bit of story, like, that's not necessarily... He had been shopping this paper around for a real long time and was having a lot of difficulty getting it published. And so when he decided that there was no place for sort of theoretical studies on evolution, he started his own journal, and this was the first paper.
That's why it looks like it was typewritten.
I was
'Cause it
wondering
was.
about that.
Yes.
Does it still
So-
exist today?
Evolutionary. I think it might have ended sometime in the late 90s. So it lasted for a real long time, and
Uh-huh.
it's easy to sort of like couch, oh, he made a journal just to get his paper published, but like that journal actually did have a bunch of different evolutionary theories from a whole bunch of different areas, and it specialized in people who are willing to look outside of the box or come up with weird and unconventional theories.
Yeah. There are two ways you sort of get a new journal come about. One is because there is a genuine gap for a niche in the field to publish, which is, I think, this case. And then the other ones, which are like Archie Lamont, that just wanted to publish on how great Scottish geology was, so created the Scottish Quarryman's Journal and just published his own papers on it, including how animals are consistently mimicking other animals in the fossil record and other crazy such things, including
That sounds funny.
created his own unit of geology, which was better than everything else. It was called the Pentlandian. It was only found in Scotland. Stuff like that.
Yeah, that was definitely not the case here. Although, because he was starting off a new journal, like the first volume was predominantly his work because it was difficult to get authors.
Yeah, it's unfortunate because those are things that will be looked at more retrospectively because the circulation won't be so high as they start out.
Yeah. So what Van Valen did is Van Valen generated survivorship curves. Now, in modern ecology, a survivorship curve is basically the proportion of animals in a population that or plants or whatever in a population that will die off at any given age.
Yeah. And it generally sort of increases as you get towards adolescence and then senescence.
Well, there are sort of three general patterns that can happen. First off, you have a species or a population, let's say, where there's very little infant mortality. So you tend to survive well on into adulthood and then die mostly of old age. And so those, generally speaking, are going to look kind of like a 7, where there's almost a horizontal line at the top where like nearly 100% of your species of your individuals survive until, let's say, 60, and then they start to die off, and then they reach a threshold point where they pretty much all die off. The converse is something like, let's say, sea turtles, where if you're really young, you're more likely to die off, but if you reach a certain size, you're fine. And so that's going to give you like an L-shaped pattern, where you're going to have a massive mortality early on, but you reach a certain size and you're fine. And then the final pattern is more or less a linear pattern, and that just means that if you have a straight line going through there, each individual has just as much likelihood to die off as any other individual.
And it was that final pattern.
Yes. So he did snapshots of the modern, as well as also fossil data, and this is where I think we can get into some oddities with some of his interpretations or what any of it actually means. But he did sort of snapshots of the modern and looked at like modern genera. So he didn't look at species, say, for a few foraminifera. And some of those foraminifera he claimed were species that have been surviving for 40 million years, which I don't know about that. I don't know enough about foraminifera to know if species could last that long.
I know the average age for foraminifera is about...
I saw it's 5 to 10 is what I thought.
Yeah.
Okay.
I can remember the figure. It's in a different paper for that. There are some outliers, but I think 40 is a rather.
That seems a little excessive.
Yeah.
Regardless, he was looking at genera for the majority of his data and trying to see if how old those clades were, and he came up with linear relationships for all of them. So any given clade, it seemed like if you were at least 1 million year old, you were this proportion, and if you were so basically he looked and found that there was a smaller proportion of older clades and a higher proportion of younger clades, but if you were plotting out like an age for clades through time, that there was a linear relationship. And what that implied is that at least at any given snapshot in time, your probability of going extinct or your potential to go extinct is independent of your age. It doesn't matter how old you are as a clade. You're more likely to, you're equally likely to go extinct at any given time. Or at least that's how he interpreted it.
Yes.
And so he created a law out of this called the Law of Constant Extinction. And this is where things get a little muddied, because a lot of people took this idea and said that this meant that extinction was constant through time, that speciation and extinction were constant through time always. Like that everything always had an equal probability of going extinct and speciating.
Which we know isn't the case.
Well, and it's weird because Van Valen knows this isn't the case. He actually spends 5 pages talking about how rates can change through time. And so he instead tries to couch it in this notion of like at each individual snapshot.
Yeah, he's taking it ahistorically. He's treating them as photo frames. It doesn't matter what your history is. You could be on a precipice and you've got an equal chance of dying as something that's happily safe in a house. It doesn't matter about where you are or what you're doing or what your history is. At any particular point in time, something's going to happen, and it's almost random as to whether you're going to survive or not.
Well, and then also he did sort of note that there were similarities in linear patterns through time, so that certain things had similar slopes. And he sort of attributed this as an ecosystem base, that things that were locked in similar adaptive zones, as he called it, were all sort of experiencing similar laws of constant extinction. So it was like if you are all in this one adaptive landscape. And I feel like adaptive landscapes are an idea that we could probably have a whole nother fucking podcast on, but I'll try and paraphrase it as much as possible. If you can imagine, if you will, a map of like adaptability, and there are peaks where things are more adapted, and so he kind of imagined this situation where things in similar ecological guilds are all on a similar map, and they're all vying for resources on that adaptive landscape. And any success from one group is going to result in necessary failure of others. But then in turn, that will result in them moving further towards an adaptive peak, which will cause failure in the other.
Mm-hmm. It relies very much on everything using equal resources and there being a finite amount of resources.
Exactly. Amanda, you had something?
I forgot what it was because it was like 3 minutes ago.
Sorry. I kind of rambled.
No, it's okay. It might come back to me.
Okay. So yeah, he actually, though, getting to this notion of the potential for differential speciation or extinction through time, or rather, I guess, it's very interesting. He makes a few lines in there that definitely makes it think like he doesn't believe species have any reality whatsoever.
Which is I guess I don't know if I want to say recurring concept in biology today.
I think that's fair to say. Back and forth between. I would say I think back and forth between whether or not you're thinking of things more phylogenetically versus if you're thinking of things as populational processes. I do think that that's a discussion as to whether or not multi-populational systems actually have some sort of reality beyond just the sum of their populations. Mm-hmm. I think that's a big debate. Mm-hmm. But more fundamentally, he actually goes in to say, for at least justifying his choice of the genus, that he says that the genera rarely grade into each other, whereas species almost often do. So he's implying that there's pseudo-extinction or pseudo-speciation, which is just where you have anagenetic change, that you've claimed 2 species are different, but it's just because of a gradual change through time. And I think you have to remember this is coming from 1973, before there were any major morphometric studies to show sort of punctuational patterns in the fossil record. Mm-hmm. So any notions of like rapid adaptive change before reaching sort of either a stabilizing selection or any form of stasis, it wasn't really on the books.
But it's a very interesting. It's not quite a contradiction, but the fact that he is not happy with the definition of species being that most people's idea of a species perhaps is a snapshot in the evolution of a lineage, but he is dealing very exclusively with snapshots in time in terms of extinction probability.
Yeah. Oh God. Anyway, I feel like I walked myself away from a point. The idea of differential success and extinction all comes from his idea of these adaptive landscapes as being like gel. And so the gel is he imagines the adaptive landscape instead as like a landscape of resources, and everything's trying to pull up as much resources as it can. And if there's higher extinction rate, it just means there's less resources there. But this is kind of interesting because these are things that are going to come up in later interpretations where they kind of get muddled. And anyway, do we there was one thing I wanted to discuss with you. It was just like a throwaway line. He mentions that the idea that a species that an ancestor species could persist after speciating flied in the face of basic Hegelian principles.
That is an interesting topic, and again will almost exist based on a divide on how you view evolution and whether you think the key is genetic frequency at the population level or if there is an overarching sense of species.
I mean, but he directly links or cites Hennig 1966 on this.
I know exactly what figure he's thinking of. He's thinking of that figure that Ed likes to wheel out of his tokogenic versus phylogenetic, and it's because Hennig has the branches as species an awful lot of the time rather than the nodes. And so you'll have your ancestral species, and that will split into two, and that ancestral species technically no longer exists because instead of being A, it's now A prime.
Oh.
Okay.
And I don't know how much Hennig really believed that. The first time I really see people tackling that ancestor species can survive post speciation is in the Punk-Eek paper when I really see it explicitly graphically shown.
Yeah, he was citing the Punk-Eek paper, which had just come out, as being like evidence of something that flies in the face of basic Hegelian processes.
Hennig will be gradualist sometimes, so
I mean that's true. I think also, and I mean this all depends on how you perceive things. I think there's a difference between a functional need and a philosophical need. And I think Van Valen very much is someone who is going to be thinking about things on the deep philosophical sense, whereas Hennig might have been thinking of things strictly utilitarian. Like, you always have to treat in phylogenetics your sister species as being sisters, not ancestor descendant, because you can never find that out on phylogenetic methods.
Yes.
It could be the case, but you can never know that.
But it's interesting to sort of potentially derail this further. There was a time in the late 80s to about the mid-90s, and there are some people that still feel this today, that if a species has no autapomorphies, then it's an ancestor of its sister species. And people keep sort of thinking that, especially if it occurs stratigraphically beforehand. And this sort of ties into the concept of chronospecies that some people still very much cling on to. So, you're right, it's kind of antithesis to some of the concepts, but there are people out there that take that concept very, very seriously.
Yeah, no, I agree with that. I think... So anyway, I guess getting us back on track, we get this pattern that he sees of survivorship curves of genera through time, or rather genera in a snapshot. And he assumes that means that extinction is independent of age. Everything is equally likely to go extinct. And so he uses that information, although he very expressly states that one law, he calls it a law, the law of constant extinction,
Mm-hmm.
that one law isn't the only necessary thing to have the Red Queen. Kind of a good way of hedging his bets in case somebody comes out of the data and says, this is all wrong. But
that's something you've got to do.
Yeah, I think that's legit. Like, here's what inspired this, but just because this is what inspired this doesn't mean that this is the only thing.
Well, I mean, people have applied this beyond extinction to rates of evolution and other things like that. It gets bandied about, and I don't know if we'll talk about this later, bandied about an awful lot directly in terms of competition-driven extinction as opposed to other forms, both of which are kind of not what Van Valen was saying.
Yeah, in a way, although he definitely does. So he goes in and formulates his Red Queen hypothesis, which is this notion, as we kind of touched on earlier, of a zero-sum game. And in his zero-sum game, he does sort of state that extinction and speciation are largely linked processes. So because everything is all about this one, like, available pot of gel resource, that we would expect constant potential for speciation and constant potential for extinction. And he does kind of muddle things and say, like, he kind of throws out the, oh yeah, sure, we could have larger extinction events, but he sort of throws them by the wayside as being relatively rare, and really tries to focus that his pattern really does suggest that everything is biologically mediated and that all extinction and speciation is strictly competition. So that basically one thing, if it does really well in what it's doing, it is going to diminish all the other members of its similar ecological regime.
Yeah.
But those things being diminished are going to fall off their adaptive peak, and selection is going to drive them up their adaptive peak, which is then going to cause them to diminish the thing that diminished them. So everything is constantly fighting and running and changing and constantly adapting and moving into disparate patterns, but it's not going anywhere. It's not making any headway. It's
kind of balanced by constant movement.
Yes.
The interesting thing, the interesting about the theory and the way it's couched in terms of being a sort of constant chances sort of thing, irrespective of age, is given law of probability, you are going to get random bunches and extinction events globally through time.
Yeah. In fact, yeah, you could even argue that because all of it is probabilistic, that you could even view radiations and mass extinction events as just it happens. Yeah. Like it's a random series of probabilistic events.
Yeah. The one thing I am interested in, and I don't know if I missed this because I could only skim it very briefly and read it a long time ago, or if there was anything else following it. Actually, they came out a lot later, so it'd be something else following it. Was there any take? I wonder what his take on Sapkowski's diversity curves would have been, because you'd assume that diversity has to be relatively constant given a Red Queen scenario.
Yeah, I don't know.
Yeah.
I don't know if Van Valen ever addressed the evolutionary faunas.
Yeah. I mean, you could see a couple of reasons why.
That's when we talked about Sapkowski. I remember now.
Yes, when you spent 12 minutes talking about the Edmund Fitzgerald, and I edited it down to 4.
Yeah.
That's why you don't remember it.
Yeah.
Thank you, however, for giving us the greatest title we ever had. It's all been downhill from here.
I do one thing, I do it well. What can I say?
So yeah, I don't know if Van Valen ever talked about the evolutionary faunas. I just don't know.
I could see again that could happen. You could explain it one of two ways given a Red Queen scenario. Either sampling error in the past, or I mean, it would kind of fit in like the evolutionary faunas are better. When the evolutionary faunas were originally proposed, they were couched from a rather Red Queenist kind of perspective.
I wouldn't necessarily say Red Queen. I think I don't know if Sapkowski would have been thinking of the Red Queen.
No. From a superiority of organism perspective.
Yeah, there's some language there about either, if not adaptive superiority, at least adaptive complexity.
Yeah.
That these things are ecologically more complex and able to fill and divide niche space better.
Yeah. But Van Valen doesn't say explicitly that. I mean, he says that speciation extinction rates are kind of linked, but he never says explicitly that they're going to be equal.
Well, I think a more Yeah, he never does. He never does say that. He says the probability or the potential.
Yeah.
I think a more fundamental question is, if you actually look at the data that he's drawing from, what does it mean? What is the ecological or adaptive association of the entirety of mammals or pelecypods, like, or cephalopods? Like his groupings are all phylogenetic, but he assumes they're adaptive zones. Like, they're whole clades. It's not just like this is like woodland deer. This is all clades.
Well, it's like the Star Trek doesn't do this specifically, but Star Wars syndrome.
Star Wars syndrome?
Okay, look at planets in Star Wars. They all have one fucking environment. They're snowy, they're hot, they're jungles. Earth has all of that. So if you treat climate like a Gestalt thing, you're going to make really unrealistic things like they do with Star Wars planets, and it's the same if you treat it with groups of animals.
I thought we were going to go the South Park joke and just have it be, what, you think everything's like Earth, where there's like lions and tigers and bears and Jews and Muslims? No, there's a planet of bears, a planet of lions, a planet of deer, a planet of Jews.
No, I'm not going to say it. It's tempting, but I'm not going to say it.
What aren't you going to say?
Would you move to the planet of Jews?
It was something along that lines.
Did they blow it up? Are you slowly encroaching on the planet next door?
See, I'm
No, we're just going to get kicked off of our planet by the European planet.
Yeah, I was
Hey, you cannot treat Europe as a single fucking thing.
Yeah,
we're just Star Warsing it.
No. What is Europe then? What is your average European?
I don't know. Someone who talks about the euro a lot?
So they're either German or English.
They use trains.
Oh,
German.
yeah,
Quite often.
Mm-hmm.
Yeah, use trains.
Yep. Mm-hmm.
Always complain about American cheese.
Because it's rubbish. You
Besides
eat
the
plastic.
Point, James, I'm just giving you generalizations. And actually, there's a fun little history of American cheese. Apparently, American cheese started as a term for cheddar that was made outside of cheddar. So it was like American cheddar, and it was cheap cheese that they could sell in England. But then that went by the wayside, and so they brought back the term as an advertising campaign in World War II, or I think it might have been World War I, when they made pasteurized cheese product in an effort to sell it. So originally, cheddar was American cheese. Thank you, Wikipedia.
I think you made him speechless.
I've actually heard this story before because I have just had to sit through this from him before. I'm trying to think of a witty comeback, but no.
I really think you already came up with the witty comeback of my stories are old and stale.
Much like your cheese.
Oh,
that was good.
His stories also come in a tin, much like your cheese.
No, they come wrapped in cellophane. God damn it!
The American way.
And he
fucking
just,
A, rock, flag, and eagle.
Rock,
flag, and eagle.
Rock and roll.
Oh,
well, no. Yeah.
I was thinking we were assuming of. I thought that was the moon, which you rather nicely claimed when he fucking landed on it.
Hey, I didn't see you guys getting there first. It was
the Vikings got there first. The fucking Vikings got there first. No, okay, I don't think I've explained this in the podcast before. One of the most embarrassing moments of my life has been the realization that as a child I was getting confused about the name the Viking Moonlander. And I used to sit there and think, that makes no sense. Was it made of wood? How did they get up there?
Really, James, never count out the Vikings. They're very ingenious people.
Oh my god, that's glorious.
Mm-hmm. See, I really like the fact that a wood spaceship is like classic Jules Vernean logic.
Yeah.
That's amazing.
So anyway, I guess if we want to get back to the idea of mammals as the group he's looking at, like, do you think he's? I mean, he mentions adaptive landscapes.
You've got a basic problem of that there are predators and herbivores.
Yeah, but I mean, he mentions adaptive landscapes before, and if he's thinking of things in a Simpsonian idea, which is that, like, Simpson imagined, Sewell writes adaptive landscapes, which was only intended to describe adaptations within populations, and applied these sort of notions of local optima to, like, whole species and clades. So he imagines that mammals have to occupy some sort of adaptive superiority, and they occupied the mammal area of the ecosystem.
Actually, this is kind of interesting. If you think about it, aside from trophic zones, or actually kind of trophic, but if you take it aside from genuine interactions, but you think, what do they have in common? Oh, they're all endotherms.
Yeah, but that's a synapomorphy.
No, I know, but I mean, maybe that's where you're coming from more.
I mean, it could be. I just think it was Simpson's very imaginative way of viewing what he was determining was mega evolution. The jump between the jump between forms, like, of larger change. He claimed was
the
mega
problem
evolution.
with that is that theoretically, if a mouse really, really willed it, it could become a bird.
Yeah,
Bats did it first.
Bats were mice that really, really wanted to be birds.
Actually, I guess they were moles, but small mammal, whatever. Fuck mammals.
Varmints, it's fine.
I'm pretty sure they weren't moles, because once you go mole, you just can't go back from being a mole. It just sucks.
But early bats have mole teeth. They have teeth that look identical to I can't remember the exact group, but they look like mole teeth, mole molars.
I know, but that just because you.
I don't know if anyone has done a reconstruction of bats. I don't know where bats are actually derived from.
Well, the problem with that is that we just get bats. I mean, we don't have any kind of bats. The earliest bat fossils that we get are bats already. And so we don't.
Do we have any molecular studies? I mean, there have to have been.
Yeah, there's been stuff,
right?
but
I shall use Google.
Wait, okay. James is fact checking us. This is scary.
No, I just want to. My main point is, just because something shares a character with something doesn't mean it evolved from it. They could have a shared ancestor.
I know they could have a shared ancestor, but that's not. It sounds cooler to say they were moles. God damn it!
It's also factually inaccurate, and that's not what this podcast is about anymore.
Yeah, we're all about factual accuracy.
Bat. Okay.
Please don't tell me you're using Wikipedia.
Bats are
yes.
Fine, I'll change the webpage. Bats are mammals of the order Chiroptera. Blah, 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 blah,
blah, blah, blah, blah, blah.
Bats,
all those facts getting in the way.
Bats are mammals. In many languages,
Really?
The word bat is cognate with the word for mouse.
Okay. That's not helpful.
I was going to say, but...
Bats were formerly mostly thought to have been closely related to famous lemurs, flying lemurs, tree shrews, and primates, but recent molecular cladistics research indicates they actually belong to a diverse group also containing carnivora and artiodactyla. That doesn't tell us anything. Okay. No, these are...
It also...
They're not rats. That's fine.
It also kind of depends...
They're part of the order Scrotifera.
Amanda, before that, what were you gonna say?
There's some argument over exactly. Let me see if I can remember this correctly. I don't remember if there's argument over whether or not bats are actually monophyletic, but like, at one point there was some evidence that the so-called Megachiroptera were like more closely related to primates, and the other ones, the Microchiroptera, weren't. This is what happens when I don't read this stuff for like a year.
Well, anyway, how about we take a minor detour off of bats back to the Red Queen?
That's probably a good idea. Although this is the first time I've contributed anything all podcast, so
I feel bad now. We'll talk about bats.
No, it's good. I'm apparently so out of it that it's probably
it's free.
What?
Nothing.
Okay, your internet just went out. You're still here though.
I'm here.
Okay. So I guess the basic pattern is as we suggested, this whole zero-sum game of everything competing and constantly adapting but getting nowhere. And that's where the Red Queen comes from. It's from this excerpt from Alice Through the Looking Glass, where Alice is running and running and running with the Red Queen, but not going anywhere. And she asks the Red Queen and says, what is it, James?
Nothing.
Okay. Well, she talks to the Red Queen and asks why they're not going anywhere, and the Red Queen says, you have to run very, very hard just to stay in place here. So that's the metaphor of the Red Queen. And taking that idea, Stenseth and Maynard Smith did a model of evolution based upon whether or not they thought, rather they were looking at models of phenotypic change within ecosystem populations. And they modeled it based after island biogeography, sort of Maynard Smith's own lag load sort of models, and the Red Queen. And they wanted to see whether or not, through time, if it was likely that either Red Queen scenarios held or sort of a stasis, where evolutionary stasis held, where basically things changed evolutionarily and then stuck there for a while until they were disturbed. And their model results suggested, given all of their distributions, that there were two likely possibilities. Either everything keeps changing like the Red Queen, or things change till they reach a standpoint and they stop. And the only thing that will cause them to change again is some sort of environmental disturbance that will cause the whole system to get jumbled again. And I guess that's kind of like that's sort of what frames the modern discussion of the Red Queen, because with that test, Stenseth and Maynard Smith frame the entire question as being, if everything is constantly changing like the Red Queen, then everything in evolution is all based on competition, and it's all based upon biotic interactions. And if instead things tend to stay static and then change abruptly when things change, when there's environmental changes, then that suggests that the primary mode of evolution and extinction is abiotic, that it's historical, that it's the series of historical events that are affecting the evolution, as opposed to this sort of constant engine of change that is biotic competition. And I guess getting into, I guess what we'll talk about maybe a little bit later, that's really what changes the argument a little bit away from how Van Valen originally interpreted the Red Queen hypothesis to, I guess, the logical extension of those ideas. That
right,
it ultimately
because, I mean, these ideas have to be open to change, and we can modify these things as necessary. That's why James and I were kind of having this conversation earlier, whether or not it was like still valid to call it the Red Queen or not. And I think it is, even though the concept has changed slightly over time from what Van Valen originally sort of came up with. It's still at its core sort of the same basic concept. It's just been changed a little bit more because we have better evidence, I guess. Not better evidence, but more updated evidence.
We have different evidence. I mean, we're not just looking at survivorship curves of clades through time.
Right.
I mean, that was his basic evidence.
Right.
And I think we can make arguments back and forth as to whether or not that necessarily supports his Red Queen hypothesis. I think if what he was recovering was constant extinction and constant speciation, maybe. I don't know, but instead he's just saying age independence, and I feel like if things really are, if the pattern is true and it's not just an artifact of paraphilia and other things, then the fact that supposedly ecologically similar things all have age independent extinctions, that might actually suggest that if you're adapted to one thing and the environment changes, guess what? You're all equally likely to go extinct. Doesn't matter how incumbent you are, or how old you are, you're all equally likely to go extinct. And I don't know if that necessarily suggests what he says it suggests.
Bats are sister group to a group consisting of carnivores, artiodactyls, cetacea, and perissodactyls.
Now we know.
Mm-hmm.
Okay. On that note,
James.
do you think it'd be okay if we take a break?
Yeah, that was kind of my thought. I figure we discussed the basic patterns and the sort of evolution of the idea, and then we can get to the papers discussing the potential shortcomings.
Sort of like in the modern era.
Yeah. I mean, we got that new Vermeer paper, which was sort of the impetus for this whole thing. We might as well talk about it at some point, right?
Sure.
All right, let's take a break then.
So I guess are we back?
Sure, we can be back whenever we want to be back.
Yeah.
Are you back?
I guess in a non-existential way, yes, I'm back.
We were back
Okay.
20 minutes ago. Why not?
Okay. We never really left. We've
Yeah.
always been here.
That's true.
And we are eternal.
Well, it's like that concept of how some students think that their teachers just live in the school building.
We actually live inside your earbuds. We've been meaning to tell you this for some time.
It's true.
Yeah. It's like the guy who lives in the ATM and hands you
I
cash.
am the voice inside your head.
This podcast doesn't actually exist. Thankfully, it's not telling you to do anything. It's just having you listen to science.
That's true. It could be a
Buy
lot
gold. Buy gold.
No, we are not doing that shit. No, do not Glenn Beck us.
worse.
No
God.
fucking Fox News bullshit here.
Watch CNN.
You're right. That was not Fox News bullshit. That was a whole other. No. If you want to do CNN jokes, you should poll the community to go to Twitter and vote on whether or not they should see CNN, and then report that as news. See, Amanda laughed, but you did because you don't understand how sad fucking CNN is. This is the real tragic thing. The one unbiased, like, truly supposed to be great news network has fallen into just sad fucking decay.
Once we adopted 24-hour news in the UK, it just existed on specific 24-hour news channels, so like there's BBC News 24. And that is about 18 hours of looking at the front doors of buildings, waiting for something to happen, while people say the same 4 sentences over and over again. And then something happens, and people get excited, and it's the janitor leaving.
That is CNN. That is CNN. Is we see a helicopter, we don't know what it's doing. Maybe it's going to an accident. We don't know. Tweet us and ask us if you know anything about it, and we'll report it.
Tweet us and ask us if you know anything about it.
Yep. Yep.
It's about as bad as that slip of the tongue.
Yeah. Well, it's like, I mean, this is not the pinnacle of internet news, but I get my non-institutional email via Yahoo, and they seem to think that questions asked and answered by random people on the internet on their Yahoo Answers page somehow counts as front page news.
Again, as I said to you before, Yahoo News, not necessarily the source, like the spokesperson for reputability.
They do have a very cool story about a Greenland shark that was found washed up trying to eat a moose.
So anyway, I guess we talked about some of the early formation of the Red Queen. Do we want to get into a little bit of some of the various ways it's been attacked?
Sure. I mean, when it comes down to it, the main one is that it always comes down to is the importance of biotic versus abiotic influences on evolution, right?
Yeah, definitely. And I think this is where you have both Verba and Barnowski really coming at it from not only an abiotic... what?
So I'm just going to say, the Barnowski paper, and Amanda can verify that this actually happened. I got past the first page, got to the table on the second page, and I'm like, what the fuck is that?
It's true. He was very loud. He scared the cat.
Yeah.
And then he yelled something about how tables are supposed to be concise. I'm not reading this bullshit.
So, Barnowski is an extension of Verba, and Verba was originally looking at the turnover pulse hypothesis, and she framed her original turnover pulse hypothesis as a alternative to the Red Queen.
Mm-hmm.
That you could imagine situations where there is a abiotic engine for speciation and extinction, and due to sort of differential differences within the within individual clades, like let's say there's species that are more likely to have their populations fractionate because they're specialists, where there are generalists that are more likely to just sort of weather the storm. You okay, James?
Yeah.
Okay, good. So you could have certain clades speciating extensively, certain clades speciating very little, and that if you took those patterns as all being sort of based upon major punctuations of environmental change through time, that you could create a pattern that would show survivorship curves similar to what Van Valen was recreating for his data, and assuming the Red Queen.
Yeah. Was it the Barnowski paper, or was it in Van Valen's one where they say that... Yeah, I think it's Van Valen's one where they say the rates are specific to the clades and doesn't suggest that the rates are the same between different clades.
I don't know exactly. Van Valen certainly suggested that the probability of extinction, or the possibility of extinction, that the kind of slope of that survivorship curve should be consistent across taxa that are all in similar adaptive zones.
Yeah.
So he imagined the world as being locked in these adaptive zones that are all competing over the same resource.
Yeah. Yeah. It was very interesting when you read the start of Barnowski's paper, that they sort of... they take it from a very... looking at it far too macro a scale and overgeneralizing and using broad brushstrokes to paint over the minutiae, which means you're going to naturally get a sort of a median agglomeration because you're trying to take the median of everything.
Yeah. And I think so. I guess getting to Barnowski, as I said, as a kind of revision of some of the earlier stuff going on.
I guess, do we need... I guess, sorry, because I just realised that I just started talking about Barnowski because I remembered more about... I mean, I know the Verba paper, but I remember more about Barnowski that made me chuckle. Do we need to explain, like, your turnover stuff and stuff like that?
Didn't we do that in an earlier podcast?
I think we might have. The basic tenets of the turnover pulse hypothesis, though, is that if you have some sort of oscillatory climatic pattern, that you can have that affecting species ranges and causing them to either contract or expand through time, and that contraction during periods where there's extreme contraction, you can have major population fractionation, which is one of the key points for allopatric speciation, or speciation by the separation of populations. And so that's a key, the disrupting of breeding between populations is like the key point towards getting meaningful divergence across populations that would start speciation. And so that's sort of her motor. And then she also mentions a little bit of what she calls the effect hypothesis, which is that individuals that might have a key, like either adaptive preference at an individual level, that characteristic might have an upwards causation to dynamic patterns of their clades. And this is what I was getting at with, like, she looks at impalas versus... water wildebeests?
Wildebeest or yeah. Anyway, yeah. Bigger antelopes and smaller antelopes.
Yeah, bigger antelopes and smaller antelopes. And she finds, the one group is highly generalized and has very few species, but it also speciates and goes extinct very rarely through time.
Yeah.
Whereas you've got the highly endemic, because they have, or rather they're highly specialized in what they eat, and they also tend to speciate more rapidly, but also go extinct more rapidly. So she suggested that this is because if you only eat one food source, you're more likely to be strongly selected by directional selection at the individual or population level, which then in turn means you're more likely to experience either major adaptive shifts or more likely to go extinct. And that has an upward causation towards higher speciation and higher extinction, because the very characteristic at an individual level makes you easier to become fractionated, for your populations to become fractionated, because it's harder for you. Let's say if we divide up your resources, it's very easy to divide you up so that it's hard for there to be intermixing of your populations, because you're very stressed. And so that means you're more likely to experience allopatric speciation. Furthermore, since you only eat one thing, you're also more likely during that time to experience extreme directional selection.
Mm-hmm.
I was probably ridiculously rambling and probably made it more confusing than it need be.
That's just like Van Valen's original paper, then.
Yeah, but Verba's
That's
paper is a
accurate.
little bit more intelligible than never mind. I love Van Valen's original paper, but it is a slog to read.
It's amazing. It takes this core concept, which is actually at its heart rather elegantly simple, and then wraps it up to make it as complex as possible.
Well, if you his website, which he had for University of Chicago, is still up, and it's actually kept like as sort of a memorial to him. And his like paragraph long block of text explaining what he does is fascinating. When it starts off like, I consider myself to be an academic generalist. I don't really prescribe to doing any one thing.
Yeah. Whereas Verba's papers are sometimes very detailed explanations and case studies, but always explained with very clear figures. Well, usually very clear figures.
Wait, what?
I think he was making a joke there.
No, I was suddenly remembering a very specific figure.
You're suddenly remembering the fact that occasionally Verba's figures are a little bit too detail-oriented and a little bit too hard to fucking understand.
Yeah.
Again, love... I kind of want to put this out there. Every single one of the people that we're discussing here, I love all their work, even if I don't really agree with any of Van Valen's ideas. I love to death that he put them out there, and appreciate like hell that he just went out to continually champion ideas, even when people would say, I don't think so.
Oh.
If a paper got rejected, he just kept fucking trying.
I mean, a lot of Van Valen's ideas might be generally discounted now, but it's because of those ideas that we have our current understanding.
Exactly. I mean, he was
that's part of what science is.
He was one of those people who's willing to just put out a paper to get people thinking and talking. And it's also something that I really appreciate about Verba. Although Verba really does, as you said, go very much in the detailed and very logical, rhythmic, this is what this is. These are all the case scenarios that would logically come out of that thing that I just said.
Mm-hmm.
And here's why this works, and this doesn't. Which is why I kind of appreciated... her dissection of Van Valen, because I don't think she was unfair at any point. She spends her time very specifically characterizing that to begin with, he doesn't really think species exist. Like she makes this figure where she shows what Van Valen really thinks the phylogenetic tree is, and it's mostly just anagenetic lines with different numbers on it that we claim are species.
Mm-hmm.
And that's the first thing that's very important. She also mentions how Stenseth and Maynard Smith, and this is something I think we're going to come into when we talk about Vermeer's paper, because I think he falls into the same pitfall, misread the law of constant extinction. And this is, I think, the problem that a lot of people have when talking about Van Valen. They think constant extinction really does mean constant extinction through time. And that's how Maynard Smith and Stenseth modeled their Van Valen paper when they did that big model. They modeled it as a constant rate of extinction.
Yeah, but no, it's a constant probability, and constant probability is very different from a constant rate.
Well, very specifically, Van Valen meant that it was independent of your age. So no matter what, at any given time, everything's equally likely. There's no There's no favoring the old or the incumbent in this case.
Mm-hmm.
And yeah,
Because
I
if
mean,
it was a constant, if you think about it as a constant rate, there'd be a very specific age that was very heavily.
Yes. I mean, she cites a lot of, as I said, examples of punctuated equilibrium to sort of denote the idea that things aren't typically constantly changing and genetically, that there are variations in rate, so things aren't constantly moving. And then also shows an example of where you could get a survivorship curve based upon her model of turnover pulse mixed with the effect hypothesis, which is kind of the clever way of saying, here's how my model explains everything that your data explained.
Mm-hmm. Using somebody else's data to show how it fits your model is another very good tactic that you can use in such situations.
Yeah. And then the majority of her time she spends attacking the whole Maynard Smith and Stenseth model. Again, talking about the various ways that they may have misinterpreted some of Van Valen's original assumptions and how some of their assumptions might have led them to the results. And I guess we don't really need to talk too much about that. I mean, it's more specific. And I actually think Vermeer's discussion is maybe a little bit more interesting. When Vermeer talks about some of the other stuff about the problem is we have two. This is the interesting thing, and the reason why I wanted to read the Verba paper and the Barnowski paper is that this recent paper by Vermeer, which is in paleobiology, which is really great, and you should read it. And Vermeer's an amazing dude.
Have you noticed, actually, just as an aside, sorry to cut you off, Vermeer's had about 3 or 4 papers out in the last 2 months.
I have not, no.
Vermeer's got another one out in the next issue of Paleobiology. Had something before that on competition, actually. Okay. So there's currently obviously doing a bit of a push at the moment.
Okay.
Yeah, I didn't realize before this that he was the blind paleontologist. I didn't.
Yes.
I didn't realize that.
Yeah, Vermeer is an amazing dude. But the thing that I found very fascinating when I was reading Vermeer's paper, and why I kind of thought that we should at least throw in Verba and Barnowski, is he doesn't reference them. Like, he does this huge criticism of the Red Queen and doesn't mention any of the things that go into the court jester, the turnover pulse hypothesis, or Barnowski's actual depiction of the court jester. And the thing that I found fascinating about this is that you effectively have 2 different sets of people thinking about the same problem in very different ways. Because I think, I don't know if this is necessarily an unfair characterization, but generally speaking, if you were to take someone like Elizabeth Verba or Barnowski, they're phylogeneticists and systematists that like to think of things in ecological terms.
Mm-hmm.
Whereas Vermeer is very much an ecologist that likes to think of things in evolutionary terms. And so he comes up with a completely other set of arguments to attack the Red Queen. Like, the majority of Verba's arguments about the Red Queen are that, and especially Maynard Smith and Stenseth's model, is that it's all based on ecosystems. It doesn't care about the clades at all, and it completely ignores history. And by ignoring history, you're throwing out so much information that might explain the pattern you get, because the pattern might be spurious.
I'm interested here. I mean, and you might know this a bit better because you read parts of Vermeer's book. How much of that could be because he doesn't agree with the turnover pulse idea in general, or is it just that it wasn't relevant to his arguments?
I mean, I don't know. He doesn't ever mention it in the book. There's certainly elements of the book that come out in the paper. By the way, the book that we're talking about is his. It's a weird book. It's I don't mean that in a bad way. It's just you
good
need to know.
Good books could be weird.
Well, you just need to know what you're getting into, and we thought that we were getting into a discussion book based upon like theory and science, where it's really more of like almost like an extended metaphor. He basically tries to compare examples of human economy to ecology. And so it's a series of test cases where this fits with this pattern we see in economic theory.
Mm-hmm.
So yeah, there's a lot more of pattern matching than there is about like larger theory, but it's interesting in that respect. And I think that comes in a bit, but I don't know. I honestly think it's just like the people Vermeer cites, Rick Lifts, he cites a bunch of ecologists.
Yeah. A non-mixing of the fields more than anything else.
And I think that's interesting because you have systematists and phylogeneticists looking at the Red Queen and saying, this just doesn't fit what we see. And now you have a major ecologist saying, this doesn't fit what ecology sees. So if it doesn't fit evolutionary biology and it doesn't fit ecology, where does it fit?
Well, this is where it's very interesting to think about how people now sort of take this as a kind of sliding scale, and that when you are down to small single populations, Red Queen might actually be in effect, but it's in very specific scenarios.
But the Red Queen would suggest, at least as originally placed, that it's like fixed, that
Exactly.
you never stop moving. And
yeah.
all that means is that you're anagenetically changing until you reach metastability or stabilizing selection.
Exactly, and it's interesting that most of the discussions about Red Queen that try to keep Red Queen alive focus it very specifically from the extinction perspective, tied into biotic, mostly competition, but tie it very closely into when you're down to small levels, biotically, other species can cause you to go extinct, but they don't talk about the rate issue, which was the main point, or the probability issue, which was the main point of the original paper.
Yeah, I think that's interesting. So I guess we skated around it way too much. James, why don't you tell us what the court jester actually is? Barnowski's paper of the court jester.
Why do I have to explain this? I mean, from my understanding of it, and this is paraphrasing, and you can tell everyone exactly when I'm wrong, what it comes down to essentially is, if you think about it from a court jester perspective, court jesters are just chaos. They just randomly do things. And so basically your species is existing in its place and time, and if it's unlucky and the environment changes in such a way that it can't survive there anymore, it dies.
Yeah, it's kind of taking, as we sort of discussed earlier on with Verba, taking the data and say, this is how you can fit, this is how my model can fit you. It's a similar way of saying, this is how you could explain this pattern just by abiotic processes.
Mm-hmm.
That it could all just be environmental change that's creating a similar pattern. Okay. Well, I guess getting into, before we get into Vermeer's paper, I guess there's one thing to discuss beforehand, just for completeness sake, which is the reason why the Red Queen still exists is because it has been latched onto as a major component of biological evolution, specifically in explaining the origin of sex in a very sort of Dawkinsian, or at least heavily gene selection-based regime. That the paradox of sex existing is something that plagues a lot of biologists. That if the most important thing in evolution is for genes to continually perpetuate their existence, then sexual recombination basically just like cuts you in half and scatters you to the wind and makes your selfish genes disappear.
Well, this is the problem with the entire problem with the gene being the major driving concept.
Besides the point.
No, but I mean, things can be massively deleterious, and this is a way to stop those things from building up.
You mean as far as sex?
Yeah.
Well, the core actual study is kind of along those lines, but it's one of the few instances where you might see something similar to a Red Queen, although Vermeer even suggests that the pattern doesn't completely follow the patterns of a strict Red Queen, is that in the presence of a parasite...
I was just going to bring this up.
Oh, do you want to talk about parasites?
Go ahead.
I guess, yeah. Totally unprepared now.
I'm sorry.
Pretty much, it's sort of this kind of situation where if you have a parasite, I guess, parasites are host specific. They tend to be very tightly evolutionary linked to their host organism. And so this is the kind of situation where you get this kind of the Red Queen scenario where you've got the host organism trying to get past the parasite and the parasite constantly trying to keep up with the host organism, sort of. I kind of butchered that, sorry.
Yeah, no, that's pretty much it exactly. Specifically, though, the reason why it gets linked into sex is in certain species where sexual reproduction can turn on or turn off. They find that in the presence of a parasite, there's a strong selection towards sexual recombination because of this whole back and forth, because sexual recombination does help to combat parasitism, and then the parasite then furthermore is deleterious of all, then that might potentially fit something similar to a red queen. And so that's why it's been that particular case study has been latched onto as the reason for the paradox of sex. That sex exists because we're stuck in a red queen scenario against parasites that is fighting against the selfish gene.
It's actually very interesting when you look at animals that can both sexually and sort of asexually reproduce, like aphids. Invariably, when they're highly stressed, they'll just spit out tons of clones to try to increase the chance of their particular set of genes, I guess, surviving. But the moment they can, they will reproduce sexually. Because the physiological stress of reproducing sexually, I guess, is somewhat higher, or at least the amount of effort taken to reproduce sexually is higher than just spitting out clones.
That's another paradox of sex, the amount of energy that it takes as well.
But it's interesting when you're in school and people go, so why do these things that can spit out clones? Why will they produce sexually when they can? And the answer you're always given is because if there was a virus, or in terms of like aphids, if there was a pesticide that specifically that worked very well against this individual, if the entire population of clones of that individual, that entire population's gone.
Yeah. Although that does seem, at least to my ears, a bit anthropomorphized.
Oh, totally.
Nothing is ever thinking, man, if a virus hits, we should really sexually reproduce.
No, totally. But what it does kind of do in a very passive way is...
You like that one, Amanda?
Yeah.
All I can think is like a doomsday-esque type movie.
We're going to die, and you know what? I've never, ever been with... And then that's where the scene starts, really.
Joe, there's a really big comet at the moment. Talking of doomsday stuff. Anyway.
What?
There's a really big comet that you can see.
Oh.
Yeah, it could be heading right for us.
Yeah, at any moment. And there's also a major virus and fire outside the building.
Unfortunately, one of the worst viruses is transmitted via sex. So.
Yeah.
Anyway. But from a selective perspective, you can see why anything that might increase variation within a population could be selected for.
Yes, yeah, I think definitely variation within a population can be important to adaptability and to complexity. But yeah, I think whole gene-centric theory and the selfish gene is something that could be another podcast, or probably several podcasts, because there's a lot of back and forth to debate on that.
Yeah. And I mean, that's one of those things where you can agree with parts of it, but not the whole, stuff like that.
Well, and yeah, I think the key thing I disagree with is the centric element. Like, I think gene selection is very important at the gene level, but that might not 100% translate to, like, the evolution of a new species.
Yes, and I think that's where a lot of the disconnect occurs between... sort of the ecological perspective of evolution and the sort of biological
gene-centric.
Yeah.
It's very interesting. I guess in some conversations that I've had in some of the reading group meetings, I have found myself favoring more with some of the ecologists as opposed to some of the paleontologists in the room. That being said, I don't know if we agree on the reality of species, but still.
To be honest, that's something that, depending on who I'm talking to, I can swing one way or the other pretty freely. I have my own idea.
You just flitter about. You don't take a stand, huh?
Oh no, I totally believe that
You're a phylogeneticist, goddammit. How can you not believe in species?
No, I believe species are real. I don't believe we can always fucking tell when they exist.
I agree. But the argument is often that species aren't real, that they are just ephemera, and that there's no difference between a species or a genus or a family because it's all just bullshit that we made up.
I'll always say rather guerrilladly, and I know you will tell me off for this sometimes, but the fact you can tell a species are real once it's dead.
Yeah, I do think there's. I agree with you in concept. There is there's a forest for the trees argument, and I actually think if you're looking at Simpson's evolutionary species concept, especially the way that Ed kind of reformulated it in the 70s, it's very much a snapshot approach. Like what you're looking at is like a tree, and where you have these sort of within a branch is tokogenetic or population-based processes. You've got the weaving back and forth of populations that are interbreeding with each other. And as it branches away, that means that you've got potentially a speciation moment. But those might come back together, or that branch might fall off early. But at any given time, so long as they're separate at that point, they are a new species.
Mm-hmm.
Like, you lose a species maybe by interbreeding back into a previous species. Or potentially with plants, hybridization could create a new species, which is whole fucking
plants.
I really think part of my problem might have come that most of my discussions on species come from discussing with people who work on plants.
Fucking polyploid.
Lake State just scored 1-0.
Correct.
Yay! So, but yeah, no, I think part one of the big problems there is that species occur over geological time periods, and it's really difficult, even as somebody that works on that, to fully visualize that we are never going to understand within our own lifespan the dynamics of the species we're observing now, because the time frames that these work in are just too big.
Yeah. Anyway, I guess, do we want to touch...
Do we want to touch Vermeer
at this point on Vermeer's paper?
Well, I don't know. How attractive is he?
I've met the man. I think you would like him.
He's Dutch.
That was the argument you used earlier, too.
Yeah, I know.
Wait, you already made a touch Vermeer joke?
No. What? James is just sitting here shaking his head at me in disappointment.
So basically, this paper is set up almost like they're tearfully taking the Red Queen out the back and shooting it in the face with a shotgun.
I just really like. Okay, so this is really interesting because that's your take on it. And Amanda read this paper and she was like, I really don't like how he's just a bit of an arsehole about the Red Queen.
He really...
And then I read it and the first thing it says is the Red Queen metaphor. I'm like, wow, you won't even let it be a hypothesis. That's really harsh.
Fuck off. Come on. The first sentence, James, is Van Valen chose the Red Queen metaphor. That's the reason for the name, not the fucking theory.
Nobody calls the theory by its name.
The law of constant evolution?
Well, that's because he said it was a law.
The law of... Well, to be fair, he actually separates, as we discussed before, the law of constant extinction from the Red Queen hypothesis.
Do you know what we should do? We should write a paper entitled Repealing the Law of...
And then semicolons, because I can't drive 55. Because, you got to make a Van Halen reference, or actually Sammy Hagar. But anyway, when talking about Van Valen.
That would be glorious.
At some point.
So
it's as
glorious.
close as we can get. I mean, like, unless we just go might as well jump. But it doesn't really make as much sense when you're repealing a law.
Well, there are laws on the books about suicide.
Do you know it used to be a hangable offence in England? Well, only if you failed.
Everyone got what they wanted.
It was attempted murder of yourself, so they'd hang you.
Indeed. Alright, so Vermeer sets this paper up with the Red Queen was a very important idea that was put out, and it's been picked up, and maybe it explains the origins of sex, but maybe not. And maybe we just need to let it go because it's completely outlived its usefulness.
I mean, it doesn't have in there at some point, and I might have read this in the abstract, that while it may occur in very specific, restricted examples, they are so unlikely to happen that we might as well just not concern ourselves with the concept.
We suggest that that Red Queen dynamics can occur in short term in episodes of strict coevolution where two species such as a host and its parasite or a host and its mutualistic symbiont adapt to each other. Here the relevant adaptations are highly particular to the interaction. So yeah, it's basically saying it exists at a short time in very specific small populations as opposed to being a systemic thing.
Mm-hmm.
Right.
Which is basically just saying it's anagenetic change in small populations.
Yeah.
Which is again just basically stating that it's what you would expect during speciation.
I just think that what this comes down to is that Van Valen had a good idea that kind of when he went to baptize the baby, he kind of just drowned it in the font.
Backing up. I really like that the last sentence in Van Valen's paper is, this whole idea is really disturbing to me, that we're all stuck in this competitive, antagonistic, zero-sum game, and I don't necessarily like it myself, but I can't think of any way out of it.
Was this just a metaphor?
Sentence.
Do you think maybe that this whole paper was just
slightly,
a metaphor for
much.
academia?
Yeah, I'm paraphrasing slightly, but not much. Like that's It's very much I don't really want this to be true, but I can't think of anything else.
Yeah.
It
So
is
anyway-
kind of a good metaphor for academia.
No matter what, your success is always the failure of someone else. I don't think that's academia. I gotta be honest, I think you need to get out of wherever you are if you think that is academia.
There are so many things I could say right now,
That
but I'm being recorded, so I'm not going to.
was the most fake laugh I've ever heard.
I'm good at that.
Oh man, that's so much red.
It's gonna be okay. So yeah, Vermeer basically breaks down the three core assumptions of Van Valen. And this is one thing that I found very interesting in Van Valen's original paper. He was like, I've got this constant curve. There are two possibilities. Either my assumptions are incorrect or it means something weird. And he just completely glosses over his assumptions being incorrect.
Well, that's because that's the point of the paper. If my assumptions are correct.
No,
I mean, it's a model.
I agree.
I don't know.
I agree.
You can also see why it took him a while to get this published.
Yeah. I agree that you never want to just immediately tank your own paper by pointing out all the ways your assumptions could be wrong. And he does a little bit more than just simple lip service, but it's like 3 sentences.
Bemidji just scored 1-1.
Woo!
No, we don't like Bemidji, even though they're in Minnesota.
I don't know who's playing, and I don't know what's going on. I'm just going to say woo to anything you say sports related.
Well, KU did just throw an interception in the end zone.
Woo!
Who, by the way, did Indiana ever score?
Yes. It's 10-0.
Woo!
Yes, a team that actually has a worse record than KU is beating us.
No. I mean, Indiana against Ohio.
Oh, yeah, they scored 2 touchdowns.
Oh, good for them.
Sorry, that's right. We're playing Iowa State. Yeah.
Yeah.
No, yeah.
So the key assumptions that he looks at are, first off, he starts out the notion that adaptive evolution is continuous. And this is the interesting point where I think he falls in the same trap of Stenseth and Maynard Smith, where he assumes that it's all continuous.
Well, it assumes that Van Valen assumed it was all continuous.
Yes.
Yeah.
So but he's talking about adaptation rather than extinction.
he is talking about adaptation. I think this is where things get very interesting with Vermeer's paper, because everything that he's talking about is matter-energy transfer. He's talking about things in an ecosystem base, independent of phylogenetics and independent of history.
So,
Well, not. To be fair, I'm going to back it off. Not independent of history, but he's thinking of things mechanistically as matter-energy transfer.
So if he's talking about adaptation, essentially what he's talking about then is evolutionary rate of change. So he says that Van Valen assumed it was constant.
Yes,
And he says it's not.
Well, yes, he does. He specifically says it's not.
Yeah.
Because he, first off, I mean, obviously cites Eldridge and Gould and further studies of punctuate equilibrium. But he also cites, and this is where I kind of wanted to come back to this when we were talking about the Stenseth and Maynard Smith paper. He cites a revision of Stenseth and Maynard Smith's paper, which, so their original model was that, like, everything wants to be on this adaptive peak. So it's striving to get to that adaptive peak. But ecology suggests that's really unrealistic, because the world isn't really all lockstep and highly competitive and desperate to get to that peak. Suboptimal things survive just fine. In fact, that's what the population level, adaptive landscape was originally intended to describe. Like, the reason why you can have things above, that things aren't perfectly optimized, is is because the adaptive landscape is constantly moving. Nothing ever really reaches the peak. So being suboptimal is fine, because it might also suggest that you're maybe on the line to a different peak.
Mm-hmm.
So instead, they revised the model so that it wasn't just constantly driving toward the top, but quite fine to just be within a buffer zone.
If you think about it, it works very much as a Markov chain.
Yes, and that's what Van Valen used to model, and that's what Stenseth and Maynard Smith used to model.
Mm-hmm.
But they relaxed the Markov chain so that things are moving, so that there's an optimality. Like, it's okay that you're not this high up. You're just not going to care about moving anymore.
Yeah.
And when you do that, the pattern that results is stasis.
Mm-hmm.
And I thought that was really cool, that there was a subsequent paper afterwards that is like, no, you're not going to get these two different patterns of one being Red Queen and one being like stasis. The only pattern you're going to reconstruct, if you just allow for a little bit of fudging, a sort of fuzzy optimum, is stasis.
Sorry,
go ahead.
So what it comes down to when you look at that then is we are now quibbling over causes. And I say quibbling, it's not a minor thing.
I mean, are we? Well, maybe if the pattern, if you manufacture everything the way that you do, that if you take their pattern or their model and you just adjust it so that it's a little more realistic by not having everything drive strongly for the peak, but allowing for the flexibility that we see in nature, and the result you get is only stasis, then that suggests that you don't have a Red Queen scenario. You don't have constant change. You have fixed change. I will agree with you. This is suggesting, at least by this model, and it's certainly what Vermeer is supporting, stabilizing selection as a means for that stasis, as opposed to like the more passive stasis that either Verba or Niles Eldridge would suggest.
Yeah.
Like oscillation over mean based upon
this is what it comes down to. What is selection doing? Is selection driving you to extremes, or is selection pushing towards the peak of the bell curve?
Well, yeah, but again, remember, the model suggested that pushing towards the peak of the bell curve would drive constant change.
I'm just thinking of it from a case of it kind of fits neatly. It gives a reason beyond, as you said, beyond just the passive stasis. And then when you get massive sudden changes, that's when you get your speciation events and your extinction events beyond the ordinary.
Exactly. And in that case, basically what the pattern is suggesting is that, again, much like the second pattern for Stenseth and Maynard Smith, this restudy by, I can't remember the guy's name right now. Anyway, Rosenweig. Anyway, 1987.
It's not the second author on the Vermeer paper, is it?
No, that's Rupinarin. Or I can't.
Oh,
probably
Rupanine or whatever you say, however it's. Yeah.
Yeah,
I know the
probably
name.
horribly repronounced.
Yeah.
No, it's 1987 revision.
Yeah.
Yeah. But they're still suggesting that the only way you're getting massive changes in phenotype is by some sort of ecological disturbance, some sort of environmental change.
Yeah. The really cool kind of conclusions from that, from a adaptationist perspective, though, is that you're not looking at selection either being on or off, but depending on the environment, what's going on, selection just results in different things.
That's very true. Then they kind of go into this situation where they kind of establish a simple game theory where they have a 3 taxon scenario where they've got 3 individual groups that are all supposedly competing out of Red Queen style scenarios. And in this 3 taxon group, they want to try and have it so that, the advantage of one results in the failure of the others, and then that results in the advantage, etc., back and forth forever. Mm-hmm. And they run that model in all back and forth forever. Make that joke as many times as you want.
Back and forth forever.
By the way, YouTube back and forth forever. No, do not YouTube back anyway. And so they come up with all the possible ways that can play out, and only 3 of them come up with a Red Queen pattern. 8 of them come up strongly with stabilizing with some change but immediate stasis by stabilizing selection, mm-hmm. and the rest of them are stasis or stabilizing selection. So given the parameters of the model just at face value, they run several simulations. I think they end up with 64 possible alternatives, and only 3 of those 64 come up with a solid Red Queen. Everything else basically comes out as stasis. So that those model studies based with the empirical evidence, they suggest that the expectation of constant evolution is just fucking wrong. I'm
okay.
So then they go into the next part where they're talking about the idea that species are constant competitors, which I thought was fascinating.
And that's the thing that most people have focused on in the last 10 years or so in regard to Red Queen.
Yes. Yeah. That they basically suggest that the most modern data shows that it's very, very, very difficult for any species to drive another species to extinction because your niches never perfectly overlap. So no matter what, there's always going to be some place where you have an advantage over a competitor. Even if it's suboptimal, you'll do just fine. Oh, sorry, go ahead.
No, I'm saying this is when it comes down to the scale thing, where people who argue that when your species is down to a single population, which is how a lot of biologists will model species anyway, then competition can drive that species to extinction. But when you're looking at species which have got a more broader range, multiple populations, it does become harder. So again, you're looking at, technically this could be true in certain specific situations. But again, you've got to set things up just right in order for this to be the case.
Yeah. That it's a very rare instance, and quite possibly not. But at the end of the day, when you're down to one population,
something bad is happening anyway.
Exactly. It's not the species it's not the competition that killed you. It's something else that put you down to that situation. And that's what Vermeer argues, is that, and I thought this was really, really interesting, that the patterns we see in ecology is not so much it's not that incumbency doesn't exist, but rather the effects of incumbency are kind of muted. By incumbency, I just mean that if something is in your place, you can't possibly get there and you'll never get there. Mm-hmm. And the muted effect is that, okay, you can't get there, but he's not that great over here, and I can live over there, so I'm just fine. And it's that the resources aren't so finely distributed, and they're not so restricted, that it's okay if I can't be everywhere in my range. If I can just be here, whatever. You can't be here, I'm better here, that's fine.
Yeah.
And it's only the rare instances like human beings where no matter what, we will use technology to fucking find a way for us to live in your niche.
Well, I mean, when it comes down to it, Amanda, when we were discussing this just before the podcast, pointed out that island inhabitants are much more susceptible to this kind of thing, especially the introduction of like cats or rats on the island.
Right, and not only that, you're dealing with extremely isolated populations to begin with, and that was something that I was going to bring up, is what about when you have allopathic speciation, you're limited to, at this point in time, one population. What are you going to do?
It's very likely that you'll probably go extinct.
Yeah.
And therefore not actually create a viable new species. Like, it's very possible that a lot of incipient possible new species died off before they ever had a chance.
Yep.
Mm-hmm.
But I was just going to bring that up.
Yeah. And I think it's one of those cases where that is one of the cases where this kind of thing might apply to some degree. From a human, for the idea of humans being able to do this, with the rare exceptions when we're such absolute pricks that we just decide we're going to go out and shoot one of every fucking species, which we have occasionally done. What we generally do is do massive amounts of rapid climate change through deforestation or something, and that's how we drive species to extinction.
By the way, I heard recently in the last reading group meeting, pour one out for the black rhino.
Oh, really?
I believe so.
It was a subspecies, I think, or a population.
It must be a subspecies because I've seen some black rhino.
Okay.
I mean, not recently, but
never mind then.
There was definitely.
But no, there was it was like eastern black rhino or something.
Oh yeah, no, it was like it might. One of those ones where they weren't sure if it was a species or not, or now it doesn't matter.
Yeah.
Okay. Well, James, now that it's dead, can you tell if it was a species?
Well, the chances of interbreeding are now relatively low, so we'll say yes.
So yeah.
Congratulations and condolences.
Paleo After Dark, making tragedy funny.
Now how about we make a new species of elephant?
Comedy is tragedy plus time. And we have had absolutely no time, so obviously it's funny.
They're not around to be offended.
Oh, Jesus Christ.
I doubt they're listening to our or would listen to our podcast if they could.
You know, I'd like to believe that, the rhinos would just be all up on this, you know?
Yeah.
I feel like we talk about hard-hitting rhino news.
Here, this is where we could enter a Fox News joke somewhere.
Yes. And then the final thing they attack is sort of zero-sum games.
Do you want to explain that?
Well, again, we've been talking about this forever. Like, the key notion of the Red Queen is any advance that you have is ephemeral because you're just giving ammunition to your enemies.
Yeah, I kind of got what words you said then. Sorry, I completely just didn't hear you.
No problem. And they attack this in a very interesting way. First off, they say that even in some of the lab conditions, you don't really have a true zero-sum game. Because, like, even in your examples of parasitism, where sex is, like, favored, it still favors the groups that get sex. Like it's not like the...
So the jocks and not the nerds.
Yeah, exactly. Or rather that in any of their... in any of those three taxa problems...
The problem there is that female nerds just need to put out more, and we're not putting this in the podcast.
So yeah, rather that it's very difficult in these three taxon experiments to actually show a zero sum because almost by necessity somebody's got to win out because the math doesn't average out. But even more interestingly, they talk about sort of examples of mutualism and rather examples in nature of biological competition resulting in more complicated ecospace, which then fuels biodiversity.
Mm-hmm. Part of this is thinking about how competition isn't just going to drive something to extinction, but it's going to result in extra compartmentalization in terms of ecospace, and that's going to then drive up the complexity, as you were saying.
Yeah, that there's these sort of episodic innovations of physiology and mutualistic symbiosis, and this is me directly reading the fucking paper. And yeah, again, like a tiering of resources and all that, resulting in complexity and diversity and building up stronger ecosystems.
Mm-hmm.
So that at least the general pattern of ecology doesn't fit a zero-sum game. It's not like everything's locked in a deadpan race where nobody's winning out. It actually seems like it's more like modern economics. And this is where, as we were talking about that paper or the book, that comes back in of competitive economics resulting in almost a mutualistic rise.
What is interesting in a way is that both are talking about sort of modes of escalation, and escalation is something that keeps being bandied about.
Well, escalation is something that Vermeer is famous for. Like, some of his early work was studies of escalation through time.
Yeah, and it's kind of very interesting that the only difference between the concept of escalation and Van Valen's work was that he believed that things were competing so much that it was impossible to actually escalate.
Yeah. That we were on a treadmill constantly trying to outdo each other and failing. There's almost a Cold War metaphor. Like everyone's building up arms but going nowhere because no one's just bridging the gap and talking to each other. I do wonder, there are certain sociologists that look into like the socio-political atmosphere of when ideas come up.
Yeah.
I mean,
that would be interesting, yeah.
Yeah, because there is definitely some Cold War-ish vibes to that. It's coming out in the 70s.
Yeah. As I say, I mean, I just find it very, very interesting that sort of like Van Valen was so much on the escalation concept that he believed that it was just going to deadlock like that.
Yeah.
And it's very interesting, as you said earlier, to see three people, or three groups of people coming at very similar ideas, using the same concepts, but from different backgrounds, resulting in very different kind of results from these ideas.
Exactly, and it makes me fascinated because, are you okay, Amanda?
Fine.
Okay.
I'm really sorry. Your whimpering is being picked up.
Oh, sorry. I'll try leaning further away from the mic.
No, it's okay. I just feel really sad.
I'm sorry about your knee. That sucks.
It's all right.
Anyway, yeah, I guess the thing that interests me is that it's fascinating that your field of study can so strongly influence how you perceive what you're studying.
It is.
Yes, but this is one of those things that people have noted, that if you're to give somebody something that they just... I mean, this is an absurd example, but give somebody something that's kind of amorphous and difficult to work out. Somebody that looks at works on cats is going to try to relate it first to something with cats. Somebody that works on something with children's toys is going to try to relate it from children's toys in some way. You always compare things to what you know, and so because of that, it's very rare that you'll push far away from the concepts you're already dealing with.
I mean, this is why we need ideas like the Red Queen, because the Red Queen was something that attacked so many different disciplines. I mean, attacked is the wrong way, but touched, or rather challenged a lot of ideas.
Back full fucking circle.
God damn it. It challenged a lot of ideas in many different fields of biological thought. And so it made ecologists think of things in different ways, and it made evolutionary biologists think of things in different ways. Mm-hmm. And we've got evolutionary biologists forced to think of things ecologically, and we've got ecologists forced to think of things evolutionarily. Only good things can come out of that because it forces us to get outside of our wheel wells.
Mm-hmm.
Very well put.
So I guess that's kind of it. I guess any last thoughts, Red Queen?
I think we've actually managed to cover this in some degree of depth for once. So
I'm concerned that this is like a factual podcast.
This is actually the Curtis Congreve podcast.
Oh, great. Now I'm going to spend all my time editing my own voice out. It's going to be a lot of uh-huhs. Yeah.
I'm going to really enjoy this 45-minute podcast with no content whatsoever. Here's one thing I've noticed when I go, I have the same fucking profile in my audio log every time. I just go, and it looks exactly the same every time.
It's actually really useful as an editor, because I know when there's just like a completely unnecessary before you say the thing that you really want to say, because there's like an where you're like, I need to acknowledge that you said something, but fuck you, this is what I want. And every once in a while I look at that, I'm like, is the necessary for flow, or do I just cut it?
Well, you know how conversations work, Curtis. Somebody talks at someone for a period of time, then you talk back at them, then they talk back at you, and you just do that forever.
Amanda, how's your knee doing?
Pretty shitty, actually.
Oh, we're sorry.
Okay.
Oh, it's alright. It's not your guys' fault. I'm just gonna go home and dope myself to the gills and go to bed, so... After I get this sent over.
Well, then I guess at that note, I've been Curt.
I've been Amanda.
You fucking have not. I'm James.
And we're signing off.
God damn it, James!
How long have you been waiting on that one? Like, have you been listening to
you know what?
I know I can do it. It's just at some point I can fucking do it.
Long time.